So just showing off kind of how the lights work here. So we got, just gonna load up this test model. Well, I guess I'll show a couple things. So the concept of masking is probably familiar if you've worked with any, like, I think Photoshop does this. I've used it in GIMP. Basically, this is an 8-bit value per voxel that determines how much your operations apply to the voxels. And some operations have a flag to respect the mask or not. But here what I'm doing is I'm using the alpha channel in the data. I'm saying, okay, the base point is 255 and the spread is 240. So it's like anything down to a value of about 15 is going to be affected by this operation. And I'm telling it to do it at a level of 230. So that's out of 255. So that means that the value will be mostly retained when anything else happens. And you can do this by the light level and also the RGB channels. But the one that I find most useful is the alpha channel. Okay, so after having done that, this colored data that you see is kind of not exactly locked in place, but it's there. And I'm just gonna fill it with kind of a medium blue something. Like the value of 10 or something. Yeah, and so that gets drawn in there. Okay, and so that's just that. Then the next thing is the lighting, so you can clear the levels out to 0. And so it's completely black because every voxel has a light value of 0. I can go 100% red, and now it's only red. I can go, whatever, primarily green, and it looks green. I can go blue, and it looks, blue. And so this is per voxel scale factor. So we're just going to leave this at, actually, maybe just a little bit gray, I think, yeah. Okay, and so then there's point lights, cone lights, directional lights, fake global illumination, and the ambient occlusion, which is subtractive. But so, for example, a point light, if we put that right in the center, kind of like, not exactly right in the center, but do it like that, and tell it, okay, I want an orange light of some brightness, do it like here for now. Now, what that does is, for every voxel, there's basically it traces through the volume to check for occlusion back to the source. And so you see these shadows and stuff. That's actually places where it found voxels in between. Those light shafts are from it hitting something with a non-zero alpha, or everything has non-zero alpha, but this is areas where it's higher, and that's kind of where those sun shafts came from, is because they hit something on the way. So that's point lights. Cone lights, I changed the interface on this one yesterday because I think it's better. So it's in terms of a position and a target point now. So if I figure out on the Trident where I want to be high on the Y and then low on X and also low on Z. Okay, and I'm pointing at the center, actually a little bit below the center. And then I tell it I want pink, something like a medium pink, something here. Do this. And this is the cone angle of 0.3. This is in radians. Yeah, and distance power should be low actually. Yeah, and decay is basically how it uses the alpha channel. So the default value of 2 means that it squares the alpha channel when it samples through, and 3 is raised to the third power, blah blah. Where at lower values, it trends towards 1 all the time. So basically anything it hits becomes a full occluder. So anyway, yeah, cone lights, probably need to, let's widen the cone, bring this down, bring this up. No. So, okay, you see how it shines all the way through everything? That's because the decay factor is set too low. Anyway, so if I clear the light levels back again, and the accumulator keeps, I need to work that out. If you have lights too bright, it will actually not fully reset visually until you move the thing, because I'm only keeping it only runs for 8 frames after the last input, just to keep it from being crazy expensive. And after that, it's just displaying the same image. Yeah, anyway, so put that light back in, put this light back. It's a little bit difficult to kind of picture how these things are going to affect. Yeah, let's move this in. See, like, you can still see it there until I move it, yeah. And most of the operations reset the frame count since last input to 0, but you still get some remaining stuff. Anyway, so that's one of the cone lights. And if I moved it on X and Z, it's still pointing at the middle, so you get like another cone kind of pointing towards the center. You can see some artifacts. I'm thinking about doing a little bit of jittering on the sample locations, but you can see where it casts some shadows behind the voxels. I tried like all day Saturday to try and get texture filtering working, but I couldn't. For some reason, the 16-bit floating point channel, 3-channel, I guess it's actually 4, one is unused, for the lighting was just showing up black no matter what I tried, so I don't know what was going on with that. Anyway, so that's cone lights. Directional lights are in terms of a theta and a phi, so theta is rotation about y, and then phi is negative values are from above, positive values are from below. So if I do like that, and I tell it I want like something like this, probably a little higher on that, and try that. Okay, not that, and then like that. Yeah, so it's a lot of trial and error. But so one of the key things is going to be logging the values, and so I can do these operations in a repeatable way. Anyway, so this is the directional lighting. So this is a uniform vector for every voxel. It just samples through the volume backwards along that ray. So it starts at the voxel location. For example, here in the shadows, it goes and goes and goes and goes until it leaves the volume. It's actually doing the same ray test that the renderer does, but accumulating alpha on the way, and that affects how much it's in shadow. So yeah, if I rotate about that and then do something in purple, then you see it lit from the other side, and it's got shadows going the other way. So that's kind of what that does. Then the fake global illumination is a little bit more complicated. So it's like, the idea is you've got this whole volume, right? It's basically a three-dimensional grid. Each slice is like an image, right? If you were to chop out like one slice in the middle of the volume. Well, so what this does is it considers the very top slice, and then the next one down, next one down, next one down. And at each slice, it's considering 9 at each pixel in each slice, it's considering 9 rays that go up. And this alpha threshold determines what is considered a hit on those rays. Those rays are traced through the volume until they either hit something or leave the volume. If they leave the volume, they take this sky color. And if they hit something that is above the alpha threshold, they take quantity S factor times the light value that's held in the thing that they hit. So a little hard to think about, but it ends up looking pretty cool. So you can see where in a dark space, these things pretty much all the rays, okay, and that's the thing too, is up can be any one of 6 directions, like this being the positive X direction, you can see here, this was the up direction. And so you get like kind of soft shadowing here. And you see like where basically nothing lit back here because we're checking in 9 directions up this way and basically nothing hit a light source or a lit block. So if we go to plus Y and do in orange, maybe, yeah, you can see it's lit from above. And this doesn't affect any of the negative space because it's below the alpha threshold and it doesn't do the occlusion checks. So it's somewhat limited, but it works. So, and then the last one is the ambient occlusion. So it's basically summing the alpha in a 3x3x3 or 5x5x5, whatever neighborhood. And it's got like a Gaussian weight on that. Yeah, so, and then it's basically just darkening things. So 0 means it's only considering its own alpha value. And so that darkens a lot faster. But anyway, so that's the ambient occlusion approximation that's in there. 5x5x5 means that each voxel has to consider 125 voxels right around it, so that's a little bit expensive, I guess. Again, like a lot of these things are not super real time. Basically, the point light, cone light, directional light, all are per voxel operations. So every voxel has a compute invocation associated with it, and yeah, so it's basically like, yeah, it all does the setup math, it all does blah 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 to check for occlusion all the way through the volume to the light source, or from the light source to the voxel. Yeah, so this is kind of the, yeah. And you can see consequence of that is you get these nice shadows. Yeah, so anyway, that's pretty much the lowdown on the lighting. Probably go through some of the drawing operations here at some point. Post-processing right now is very simple. I just have gamma slider, and color temperature correction slider too, which is logarithmic, but that can be kind of cool too. Default is 6500. And then I've got a whole bunch of tone mapping curves that I've collected over time. Yeah, anyway, so yeah, some other settings. I've got this, so this, I described the way that the decay worked earlier. This is doing the same thing for the renderer. So if you go to 0, then everything has a alpha value of 1, and it's all, you know, like a brick wall. It doesn't, there's no transparency functionally. And like I say, I keep it at 2 because I think that gives me enough workable space, enough range to work with in the thing. The jitter amount is basically like the ray origin jitter, and so it uses blue noise. The blue noise is, yeah, screen is rendered in tiles, so they're like little pieces like that, and every frame it does a full screen's worth, or every frame that it's drawing it does a full frame's worth, and each tile gets a new offset for the blue noise. So that's a better way than I was doing it before, where I was just like having it move up and to the right, and it kind of left this like weird paint stroke looking thing. Anyway, the jitter amount defaults to like 1, I think. Anyway, and that's in pixels, basically. So, yeah, value of 20 means that we're spreading out much farther. So you get like, you know, it gets blurry. Perspective, yeah, so larger positive value of perspective means that you get this large amount of perspective foreshortening. And this has to do with the ray generation stuff. But if this value becomes negative, that's where you get the trippy hyperbolic perspective, where it's actually, turn up the volume steps. Volume steps is how many steps there are from back to front, and that has like consequences with respect to aliasing, etc., etc. So yeah, as perspective becomes more and more negative, things that are farther away actually look smaller. They look larger. Yeah. Anyway, so it's kind of interesting look sometimes. Yeah, I think yeah. Yeah, but then the what else? Yeah, scale is just, this is attached to the mouse wheel most of the time, so it's like you just scroll in and out to zoom in and out. That's all of that. Clear color is the background. I was trying to allow it to do alpha, but I don't know. It's gotten complicated. Anyway, like transparent pieces of the volume show a lot of that value through. And yeah, like I say, nothing works here. The texture stuff, okay, and so I got nans in the accumulator, so that's screwed up. Anyway, I just finished showing this off. So I don't have a way to reset that. I actually need to do something about that because this has happened more than once. Anyway, other put yeah, I did that. Yeah, the little trying to do it. You can. There's two different modes. You can have it with a Menger sponge or with a sphere. Default is the sphere. And the rest I'll look over at another date.